All right, part 2 of our lesson. Let's see if you guys all agree with this statement. Do you agree that the square root of a times another square root of a? Well, you guys tell me, what would that equal if I multiplied the square root of a times the square root of a? It would. Do you agree it would just simplify to a? Okay. I want to make sure everybody agrees with that. Now, our goal here is to figure out what type of an exponent would be connected to a root, a square root specifically. We're trying to figure that out. And so we don't know what that exponent would be. So I'm going to assign some random letter to represent the exponent that we don't know. And I don't want to use x because we use x all the time. All right? And so my maiden name that I had in high school was Klein, so I'm going to use a K. Because why not, right? We can use any letter we want. So I'm going to say that this is a to the k power. I don't know what it is, right? That makes sense? I'm just replacing the square root sign with some unknown exponent we're going to call k. And now I'm saying I'm going to multiply a to the k power times another a to the k power. And we have already agreed that that equals the letter a. All right, so let's use what we know about exponent rules. If I'm multiplying with the same base, a, what do I do with the exponents when the bases are the same? Everybody agree that I add exponents?
Yeah.
Okay, so what's k plus k?
K plus K.
It's how much? 2k, right?
Yeah.
Okay. So that's a to the 2k power is equal to a. Well, what's the exponent of the a that's on the right side of the equal sign? 1? Yep. So here I have a to the 2k is equal to a to the 1. The bases are the same, and both sides equal each other. So what do you know about their exponents? What has to be true about their exponents? Don't they have to be the same? So if the two sides equal each other and the bases are both the same, the exponents have to be the same. So can't I just say, okay, well, the 2k has to equal 1 for this statement to be true? Solve for k. K is equal to 1/2. Ah. So that must mean that the square root of a is the same thing as a to the 1/2. That's an important principle. That's an important thing to know, isn't it? Those are equivalent statements. So what we have is the square root of a, that's written in what we call radical form. A to the 1/2 power is written in exponential form, but they mean the same thing. So what would be your prediction of what the third root of a, what would that equal if I wanted that written in exponential form? A to the 1/3 power. So the index becomes the denominator for your exponent. What about this one? The fifth root of a squared. Ah, the plot thickens. Any guesses? I'll do this part. The base is a. I had that part. What do you think the denominator is going to be? 5. We got that. Well, there's only one spot left. Yeah, sure. It's a to the 2/5 power, isn't it? So the bottom number, that's still our index. If there happens to be an exponent greater than 1, then make sure that we use that exponent greater than 1 as our numerator. So some of the work you're going to do tomorrow just has you transforming between radical form to exponential form. And then vice versa, starting with exponential form and writing it in radical form. Sometimes it helps you to be able to do some math problems if it's written in exponential form. And then other times it's helpful, like when you're simplifying, it helps if it's written in radical form. So there are times that it's beneficial, more beneficial for you as a student to have it in radical form, and other times it's beneficial to have it written in exponential form. Yes?
It was like, if the 2/5 was like simplifiable, can you like simplify it?
You can. Yeah. Definitely. Okay. Questions there? Okay, one last skill, and it's on solving. So you'll definitely want your calculators. Yeah.
So this on the right side, all those three, those are like rules, like.
Yeah, well, the basic rule is this one here, is that if you have your base, right, that the top of your fraction is, if it's an exponent, and the bottom of it is your index. Yep. All right, let's try a solving problem. So let's say we have a problem that looks like this. We have x to the third power is equal to 720. X to the third power is 720. And I would like this answer in simplified radical form. That's the instruction. Well, let's see. What would we do to solve?
Square about like 3. Square root.
I wouldn't square root it.
Cube root.
Cube root it, right? Yeah. Because we want to do inverse operation, and the inverse operation of raising to the third power is doing one of these, right? So now on the left side I just have an x. But on the right side I need to do some work. Calculator is not going to be much help unless you have it in math print, right? That simplifies your radicals for you. Just make sure that you have it to the third power. Everybody else though, we're going to make some factor trees, right? 72 times 10 is pretty easy. Break it down because it ends in a 10 and a 0. And we have 5 times 2. 8 times 9. 3 times 3. 2 times 4. 2 times 2. All right. And what are my sets have to be? How many? 3. So here's a set of 3. Does anything else have a set of 3? Thank you. Anything else have a set of 3? I don't see it, right? So everything else stays, doesn't it? And it's going to get multiplied back together again. So x will equal what? Plus or minus? Do I put a plus or minus here? No. Because why?
It's only one.
Because it's an odd index, isn't it? Okay. So the 2 comes out. Third root of what? 3 times 3 is 9, and then 2 times 5 is 10, and what's 9 times 10?
9.
There you go. 2 third root of 90. Does that make sense? Okay. And really, that's how the solving goes. One more example with solving. What if it looked like this? Oops, I'm sorry. Back it up. X plus 1 to the 4th power is equal to 16. All right, what's my step? We just call it the fourth root. Very good. Fourth root. So left side has become what? Just x plus 1? What do you get on the right side?
Plus or minus 2, right?
Ah, even index. So we're going to have plus or minus what?
Yeah.
2. All right, plus or minus 2. Am I done?
Nah, you
No, you
subtract
guys.
1.
You guys.
So I have plus or minus 2 minus 1. Am I done?
No, the problem is -3. +1.
This is when you need to break it up into two statements, right?
Yeah.
So I get 2 minus 1 or negative 2 minus 1. So your two answers are?
-3.
So 1 over here and negative 3 over here. What I don't want to see is people saying, oh, okay, 2 minus 1 is 1, so plus or minus 1. Please do not do that. And I know some of you did. That's why I purposely didn't walk around the room, because I get upset. Because y'all did that when we solved with square roots too. Don't do that. As soon as you take the fourth root of something, you get two answers, break it up. You've got two different answers at that point. Break it up and then subtract 1 from both sides. Make sense? All right.